Hi, we are Insects for Food and Feed, and we are all biological engineers. I'm Jill Erickson.
I'm Laura Emery.
Rossi Bueno.
So one of the problems of today is a sustainable source of protein. So we decided to investigate alternative sources to what we currently use today. We chose to investigate crickets and mealworms. So our goal was to develop a process to extract lipids, potentially a crude oil, and a high-protein flour or meal from insects. So there are many great reasons to choose insects. 2 billion people around the world already eat insects. If you look at the breakdown of mealworms and crickets, you can see that they are very high in protein. Crickets are at 21%, and mealworms are at about 17%. Also, if you compare crickets and mealworms to traditional livestock today, we can see that they are raised on a lot less land than traditional livestock, and it also takes a lot less feed to produce an edible pound of protein.
For our project, we did a few experiments. One of them was extracting the lipid from the crickets and the mealworms to see how much we could get from them. More was on pasteurization so that when people ate them, they were clean. We also did drying experiments, and right here are some graphs of the moisture content over time, drying the crickets and mealworms at 160 degrees Celsius. The process for creating flour out of insects starts with the frozen insects. They're then put into a washer to remove any fecal matter or debris. They're then put through a vibrating screen to sift out the water and debris. Then sent through a conveyor belt dryer that decreases the moisture content to about 10%. Then through an aspirator that removes any remaining chitin. And then the dried bodies are put through a grinder to get them ready for extrusion. The extruder heats them and into an extruded cake, and the screw press will then separate the lipid from the crickets or mealworms that is sent, and the oil is sent on to refining, and the remaining pressed cake is milled into a high-protein flour meal.
Listed are here some of the alternative solutions that we've also considered for our process. And with regards to the economic analysis, we found that using mealworms as the selected insects for this process turned out to be more profitable than using crickets. And another way to measure this is the payback period of the investment. Comparing the two, for mealworms it would take about 7 years roughly, and then for crickets it would take about 24 years. So in general, certainly more innovation is needed in this area to make this a profitable investment.
Can you guys tell me a little bit more about the chitin? I'm not sure exactly what that is.
Chitin is just the outside of the cricket or the mealworm, so the harder shell that surrounds the body, and the body has all the protein and stuff in it. So that's the outside material that we have to get out that doesn't have protein in it.
So is it inedible then?
It's not inedible, but it's uncomfortable to eat. So
Okay.
again, it's removing, like, especially legs,
yes.
and the exoskeleton. No one really wants to eat that. It's not a pleasurable experience.
Okay. So what was your most challenging part of this project?
Certainly, one of the challenges was designing the process in general, just because this is insects for food and feed is such a novel idea that there's no available background yet. So that's one of the main reasons why we picked this project as well, because yeah, it would be challenging, but no one else, or there's not a lot available out there. So
So you guys are excited for the innovation?
yeah, exactly. So we wanted to explore the different ways to go about it and actually propose a process.
Okay. And what was your favorite part of this project?
I think getting live crickets and mealworms shipped in the mail and having to figure out how to, dry them and process them was one of my favorite parts. It was a lot of fun.
Okay.